Okay, so we're given this function and we have to find relative maximums, minimums, and we have to state our case as to when this function increases or decreases. So let us first differentiate the function and investigate the sign of the derivative. F prime of x is 6x squared plus 12x minus 54. And that is the same as 6 times x squared plus 2x minus 9. Now, this is a regular parabola. So most of the parabola lives above the x-axis, right, given n behavior. But if you substitute 0 into there, y is negative 54. So that means that this parabola has two x-intercepts, because most of the parabola lives in the positive, and there is a point that has a negative y coordinate. So to find the x-intercept, let us complete the square. Half of 2 is 1. X plus 1 squared is x squared plus 2x plus 1. This is the smuggling step, right? We want that plus 1 to complete the square, but we are not allowed to change the value, so we immediately subtract it. And so we have 6 times x plus 1 squared minus 10. And 10 is a square, just not pretty. So we're going to be able to factor via the difference of squares theorem, because 10 is the square of its own square root. So we have 6 times x plus 1 plus root 10 times x plus 1 minus root 10. And when we solve for the zeros of the linear factors, we get that this one is 0 when x is negative 1 minus root 10. And this one is 0 when x is negative 1 plus root 10. Square root of 10 is around 3, right? 10 is almost 9. So this is a positive number around 2. This is a negative number around negative 4. Actually, let's graph it. We have a regular parabola where the smaller root is close to negative 4. The positive root is close to 2, just for the scales. And the y-intercept is negative 54, so it's a really skinny parabola because of this multiplier of 6. Doesn't really matter. Okay. So the derivative is positive to the left of the smaller root and to the right of the greater root. That has intervals, minus infinity, minus 1, minus root 10. So open or closed interval would work, but we have an agreement that we're going to use open intervals. And negative 1 plus root 10 to infinity. This is where the function is increasing. And I'm going to make my case why we shouldn't use a union sign here. Let's just finish the problem first. We're going to come back. Where f prime is negative, that's when the function f is decreasing. That's between the two roots. So what do we have? We should not forget that this is a cubic polynomial. We know what cubics look like, right? Cubics usually look like this, something like that. But now we know a little bit more. We come into the picture increasing. The function f, this is f prime. This is f prime. The function f comes into the picture increasing. By the way, based on the derivative, we have no idea where is it, right? Constants differentiate to 0. And then there is a change in sign around this number, the derivative from positive to negative. Therefore, the original function from increasing to decreasing. That's a maximum. And now we have decreasing, decreasing, decreasing. Actually, there is a very easy point, negative 15. And now the derivative changes sign from negative to positive. So the original function will change behavior from decreasing to increasing. That's a minimum. Okay. So we can answer, here is where the function is increasing. Here is the function is decreasing. And the x coordinate of the maximum is negative 1 minus square root of 10. And the x coordinate of the minimum is negative 1 plus square root of 10. Let me just explain why this function increases on this interval and increases on this interval, but it does not increase on the union of these two intervals. Simply because if we take these two intervals and apply the union to it, making it into one set, on that set, here is a point, and here is a point. That's not increasing, right? So it has basically two separate parts that is increasing on its own, which is why we should just use a comma here. Any questions? Thank you for watching.